You're listening to Impulse to Innovation, the Institution of Mechanical Engineers podcast. I'm your host, Dr. Helen Mees. As a global community of mechanical engineers with over 120,000 members in 140 countries, the Institution of Mechanical Engineers has been at the heart of the engineering profession since 1847. The institution's mission is to improve the world through engineering by sharing the latest news, views, and insight into the creative world of technology and the people that make it happen. Virtual engineering is a process by which engineers can combine the world around them with a digitally generated environment, allowing them to visualize an object or location from a totally new perspective. While the fundamentals of virtual technology and simulation have been around for some time, particularly in first-person computer games, the application of this technology in the engineering setting is less familiar to most. Yet virtual and immersive simulations have and are revolutionising the engineering industry. Virtual engineering systems are allowing engineers to evaluate product design and customer requirements without the need for hardware or prototype samples, and are becoming increasingly common in the automotive and aerospace sectors. These data-driven simulations enable designers to accurately determine how best to integrate new components into a vehicle before fabricating and testing them, ensuring more efficient and effective products whilst reducing costs and improving safety. Virtual processors are, however, only as good as the digital and mathematical tools and algorithms that drive them, and the design and calibration of these tools requires expert knowledge from across a wide array of engineering subjects. My guest today is Professor Roy Kalowski, Royal Academy of Engineering and Airbus Research Chair in Digital and Data Engineering Information Systems at Loughborough University. In addition, Roy is also the Director of the Advanced VR Research Centre and a Fellow of the IET and RSA. Roy is a pioneer of virtual engineering and has led the development of numerous VR and AR systems, having established the UK's first VR lab during the early 1980s. As well as working for BAE Systems in his early career, he has been involved in highly classified projects for NASA, the US Navy, McDonnell Douglas, Dashell Aviation, the MOD, and many others. His research experience spans the fields of next-generation modelling, simulation and visualisation, and he has undertaken work in the development of digital twins, co-simulation and machine learning. Whilst his primary research focus is in the aerospace sector, he has achieved important developments in healthcare and other sectors. I began by asking Roy, what is virtual engineering all about? Roy, thank you so much for joining me on today's podcast. I'm really pleased that you've been able to take the time out of what is your very busy schedule to join me on today's show. I wanted to start by clarifying a few terms. What differentiates virtual engineering from virtual reality? Are these things totally different, or are they interrelated in some way?
That they are interrelated. So if we start off with the technology, first of all, so virtual reality, or VR as some people call it, refers to the actual technology for delivering a virtual or an augmented immersive experience. And so it's the devices that provide that. Hopefully they're interactive so that you can engage with those things. But people have now extended the term virtual reality and introduced this term XR, which is extended reality. So that is effectively an umbrella term, I guess, which describes virtual reality, where everything is completely virtual or computer generated. It can also include augmented reality, where the experience that the person gets is either generated by a computer, so that it overlays the real world through some form of video pass-through solution, or probably better still through an optically sort of view. So you see the real world as it really is, and it's then overlaid with graphical or other information.
Okay.
So virtual engineering is really about harnessing this type of technology to support a whole range of not just engineering solutions, but lots of activities which can include design, decision making, exploring systems before they're even built. And here we think of things like simulation, but these provide the means for people to interact and experience those sorts of systems. But for me, at least, the key really here is that virtual engineering is about generating absolutely accurate facsimiles of the real world or proposed future system.
So, as you said there, you're overlaying things, but are you ultimately wanting to create a completely independent system? Are you trying to create an environment that mimics it absolutely accurately? And how do you gather that information to be able to create that perfect facsimile?
Okay. Well, that's a question with multiple questions attached to it. And so I sort of anticipated a question like that. So the key really is it depends on what the application is, because some applications don't necessarily need a perfect facsimile of the real world. I'm thinking here mainly in the games world. But for more serious applications, such as engineering, it really is important that you can overlay information correctly over the real world thing that you're interested in, and that information isn't necessarily textual information. It could be graphical information, but in some situations, it's key that information is spatially related to the thing you're interested in the real world. And the last part of your question was where you get that data. Well, that's the challenge. In terms of creating things for computer games, there are many absolutely excellent software development or virtual creation tools that people can use now. But when it comes to real engineering data, this is where we need to better take data from professional standards, computer-aided design systems, and use that in a way that we can augment that with useful information, shall we say.
Yeah. So does that involve sort of scanning tools then as well? So you can scan an environment first and then input that as digital data?
Yeah, absolutely. There are many means. Yes, you can get the whole range of digital scanning systems today, LiDAR-based systems, camera-based systems. And yes, they will actually capture the real world to a degree. Again, it depends on the resolution that you want and how much detail that you want. So to give you an example, you could take an image, 3D image, or a data set of a particular environment. But if you do that at some distance, you're not necessarily capturing the closer detail, the much finer detail. And so you tend to use these scanning systems to capture the information that is relevant to that task.
Right.
But it can make use of other information. Don't forget that sometimes we may be interested in being able to map onto an image of the real world or a view of the real world with historical information. And there's been some excellent work where people have done 3D scanning using a LiDAR system in underground situations. I believe the BBC did an excellent series on Rome. And so you can actually use those sorts of things, but it depends on the application as to what type of data set you want and to what level of accuracy or realism that you're looking for.
Yeah. Okay. I understand. So I wanted to kind of go back a little bit in history, I suppose, at this point, because Loughborough's Advanced VR Research Centre, which you head up, has been around for a good few decades now, right? And I think you're coming up to your 30th anniversary. Is that right?
Yeah, it is. But I even started long before that, actually. In fact, the very first augmented reality system that I developed was, would you believe, way back in 1979.
Goodness
So
me.
my experiences with this technology goes back more than 30 years. It's scary, isn't it?
It is. That's quite amazing. I have to kind of say as well that I was a student at Loughborough when you were sort of teaching as well in this area. So I remember some of those early pieces of technology that we were exposed to in the 90s, thinking that that was quite kind of amazing. But you've been doing this for a long time at that point. But in the time that has passed, what overall impact has virtual engineering had on us as engineers? And what have been the milestone achievements in the field, particularly for your research team?
Okay, if we tackle your last question first, in terms of the milestones, I think perhaps the most significant milestone is that the devices that we can use today are significantly cheaper. We're talking now at several £100. Whereas in my early days, we spent over £1 million plus for the graphic systems alone, let alone the display devices. And so the capabilities grown enormously. And that's thanks to the computer games industry, where people strived for better fidelity, more lifelike experiences. So that's really pushed the technology along. There's a tendency, I think, for people to think when they talk about virtual reality that you have to wear some form of head-mounted display. And that's not necessarily the case for some applications. You can do this with tablet-type devices or desktop computers, but it really depends on the kind of role it plays. I guess in answering your question, honestly, I think it's still developing. Because you have to look at where this could actually be used in sort of industry. There's a lot of usage that people are claiming, but it's not necessarily delivering the value or the benefit that they would like. That's sometimes down to the technology not being quite ready yet.
Yeah.
But in some situations, it works really well. I guess the area that perhaps is seeing the biggest benefit is in the training world, where it's expensive to train people on real systems. And so you can start to develop virtual equivalents that will actually allow people to train with, in complete safety and at very low risk. And there are many examples like that. But in terms of its use on the shop floor, then augmented reality as a greater place to play, particularly the optical see-through systems, because you can avoid certain health and safety issues with these, because you can wear standard PPE, which is essential in many industrial settings. And you see a real world view of the world rather than something through a camera with limited field of view.
Yeah.
But the challenge here is that a lot of people have relied on things like the Microsoft HoloLens, as we did for some applications. But unfortunately, Microsoft have pulled out of that market, and there's no real credible alternative to it, other than something like the Magic Leap 2. And so I think we're going to see some really amazing developments in the future. Now, one technology that I'm particularly interested in, and it may offer a way forward, is the use of smart spectacles. So imagine wearing sort of a slightly oversized pair of sunglasses, but these then present information to the user as they're looking at the real world. There's still a lot of work to be done on these, but they may actually come forward and offer a very powerful solution, extremely low cost, and may hold the key actually in the future.
Yeah, definitely. I've always liked the idea of that. I've worn glasses pretty much all my life, and being able to pull things up or see things in a different way, just purely through my glasses, would be an amazing thing, I think. I just wanted to ask you as well about what have been the milestones for you professionally and as obviously at the facility at Loughborough.
That's a difficult question to answer in terms of milestones. It depends on how you measure a milestone. I think, going back to the very early days, spending a lot of money on systems that were very good. Being able to realize that some of the capabilities of it have increased dramatically. I'm thinking particularly here of some of the software tools that people can use. Again, I used to spend a fortune on buying some of the sort of engineering tools that allowed you to create the virtual environments. Now you can download all of these tools for free, and offer an amazing capability. There are youngsters even today in their bedrooms using tools like Unity or the Unreal Engine. These essentially, primarily game engines, but using these tools to create amazing virtual experiences.
Yeah.
And so I think people are being developed, whether they realize it or not, in being able to create these really exciting environments. But in terms of my kind of highlights, I think there've been many, really. Well, first of all, being challenged in the early days, because I was quite critical of some of the technologies. So somebody said, well, if you think that much about it, why don't you write a book? So I did. And that was the first scientific and technical reference to virtual reality and virtual environments. And that still holds ground today, even though that was published way back in the 90s. And some of the approaches I mentioned there that I used to work on in the kind of military world, still hold today. Some of the challenges that were mentioned in that book are still relevant very much today.
I think that's nice when you've been able to be challenged in that way, and then being able to put forward your case through books, through the research work that you've done, but it still is as valid today as it was 30 years ago. I think that's really amazing. As skills and competencies across engineering are becoming more interdisciplinary, do you think the need for tools that are more user-centered and provide a first-person perspective to a problem will become key to the way that engineers address technical challenges in the future?
No, most definitely. I can give you an example here in that a lot of systems and products today are definitely multidisciplinary or interdisciplinary and requires a huge set of knowledge. I'm just thinking of an example here. If you're required to be a maintenance engineer and you're in the field and need to service a particular component, you may not have come across that before. But with the use of these virtual sort of environments, it's possible that you could train, before you go and service something. Because some systems are so reliable, they rarely fail. But when it does fail, you may not have that full understanding of how that system works or even how to dismantle it. And so the user-centered approach is going to be absolutely essential. I know industry at the moment are very concerned about the looming skills shortage that's coming up. And there's a lot of knowledge that people have at the moment, but they will be retiring or moving on. And so potentially the use of these virtual engineering tools will provide that the newer generation of engineers coming through the system with that understanding, again, through sort of training and through sort of modeling and simulation. So they get a true understanding of how that system works. So yes, user-centered tools are really the future to future sort of digital engineering.
Yeah, and I suppose as we work more remotely, and particularly in some environments, wind farms, for example, out at sea, where you can't necessarily get access to technical advice very easily or support, being able to call that information up so that it's there right with you to be able to deal with a problem, I guess is going to be a real bonus for many people who are working in those kind of environments.
Yeah, it's like a portable Haynes manual.
Yeah.
People used to doing the DIY servicing of cars and things will be very familiar with those sort of books. But being able to have that intelligent assistant that's running alongside, again, you don't necessarily have to have this delivered through some form of head-mounted display. You could have that delivered through even something like a mobile phone, for instance.
Yeah.
It really depends on what you're trying to do. And I guess the key really is that the information needs to be available on multiple devices.
And as you rightly said as well, the young people that are coming up, I'm feeling quite old these days when it comes to computer gaming and that sort of thing. But the young people that are coming up are so familiar with this kind of first person interaction, particularly with computer games, that they're going to almost have those skills on hand before they've even got through their training as engineers as well, which is going to, I guess, make it a lot easier for them to assimilate this kind of new technology into their working environment.
You're absolutely right there. I think, youngsters today, this is their world. They're used to using it. I'll give you an example. I had a digital camera, an SLR camera. I showed my granddaughter some images on that, and I was simply clicking along to go from one image to the other. And my granddaughter said, "No, Granddad, do this," and she swiped across the screen. Now, interestingly, I never thought about doing that on the screen on this particular camera. I didn't read the manual, of course, many people do. But even though I use tablets and things where you naturally swipe across the screen, it never occurred to me that you do that. And another situation, my wife was talking to my granddaughter and asking her just to cite, I think something simple like 2 times table. And she said, "No, Grandma, Alexa, what is 2 times 6? And so it really, youngsters today, this is their world, that this is what their expectation is.
Yeah, so having those additional tools that can add into their environment, it's just second nature to them, isn't it? I find it really fascinating. When one thinks of sort of about virtual and augmented reality, I mean, the first thing for me, particularly that springs to mind, are heads-up displays and sort of cockpit simulators. But you're actually working on some fairly unusual pieces of technology, aren't you? And particularly in sectors that we wouldn't necessarily associate with this technology. I'm thinking specifically in sort of medical technology, smart metering, climate modelling, that sort of thing. Can you tell us a little bit about some of that research work that you're undertaking and how what you're doing in the academic setting is helping your research partners in their work out in the real world?
Okay. Well, we've done quite a lot of work in the medical world, looking at providing surgeons with different viewing perspectives of situations where we've taken, this is some time ago now, where we took 3D scans, MRI, CT scans of patients, heart data, turn those 2D scans into 3D scans, so people could look at the interaction and actually interact with that data, but in particular looking at things like the hardening of arteries and things post-operative. And so this required like a time sequence of information.
Yeah.
And so there's obviously, applications in the medical world, but the main world that I'm working in is in the aerospace world, looking at supporting decision-making, how some of these technologies can enable engineers to really understand, all aspects. And I think we're trying to break down the barriers of, design only being done in the very early stages and manufacturing at the end. I think providing design engineers with an understanding of how things are actually manufactured is really important, because it does then enable them to think carefully about how they design things.
Yeah,
how to design for for maintainability, as an example. I can't go into the specifics because that is very sensitive work, but
sure.
In terms of what we're doing, we're actually trying to break the ground in trying to identify some of the technical issues that perhaps people don't realize. For instance, most of the AR and VR type devices are mainly for domestic type applications. And most people, probably not too worried about the quality of the information or the accuracy. But from an engineering point of view, it's absolutely critical. So we're looking at things such as the tracking accuracies. This is where these devices can monitor exactly where you are in the world or in that environment very, very precisely. Whereas if you have an optical see-through system, any misalignment is immediately noticeable.
Yeah.
So we're trying to push the boundaries on how to improve certain features, if you like, in these systems.
Yeah, you've proved the technology. The technology does what it says now. Over the last 30 years, you've really proven that. Now it's about getting it as sharp and as accurate as possible, isn't it? I suppose to enable it to be as reliable as it possibly can.
Yeah. I think one of the downsides, potentially, is that you only have to look at, do a Google search or other internet search, and you realize there have been lots of devices, and they seem to have a relatively short life, actually. Not shelf life, they'll still work, but there's always new products coming on the market,
Yeah.
and manufacturers can't keep providing you with updates and things. And so you have to be really careful here that whatever you're doing doesn't become obsolete. So one of the things we're looking at is how to ensure that the environment that you're creating will work with future systems.
Yeah.
What you don't want is to develop something that only works for 2 or 3 years and then gets phased out, because the cost of these systems is still expensive, particularly if you're buying, say, 2,000 or 3,000 of them for a large factory. And the last thing you want to do is throw these away.
Yeah.
So we're looking at trying to make sure that the high value part of these systems, which is the content creation, is able to move from one device to another. I mean, that's quite challenging.
Yeah, I can imagine. I mean, do you think there's a worry as well, Roy, that the way that the term AI has been kind of plastered all over things, that virtual reality or augmented reality could go the same way? Or do you think it's much more established now in terms of its technical capabilities, and it's less likely that the companies are just going to use it as a way of describing things and not really have the systems available, sort of thing?
Yeah, let me tackle your last point first. I think AR, VR, these are well-established terms, and I think the majority of people have some understanding or concept of how these systems work and what they can do. And that's been around for a long time.
Yeah.
AI, and that's interesting. That's a very interesting topic, because when you talk about AI, artificial intelligence, the majority of people who are doing that work are really talking about machine learning, where they are training a computer to recognize patterns within a data set. Now, that's not, as far as I'm concerned, any form of intelligence. It's really just being able to pull out a pattern from previously learned data. And we still have some way to go towards what I would consider to be true artificial intelligence.
Sure. Looking at the next 30 years, how do you envisage virtual engineering developing as a field, and what aspects of it might young engineers listening to this podcast today, what might they expect to see in their work environments in the future? You've touched on it a little bit, but it'd be nice to get your thoughts on, what the future holds for this.
Okay, well, I'm never very good at forecasting into the future. In fact, I used to try that many years ago, but the technology has always beaten me. It's always being able to do far more in a far better way than I ever thought possible, But I guess in the next 30 years, and that's a long time, isn't it? When I look back what has happened, not just in the AR and VR world, but generally within IT, there's been some phenomenal developments. And even things like COVID-19, that made people realize that they could do remote connectivity and start to connect things together. I think this is where VR is definitely going to benefit, and people will start to see greater inclusion where people can be better connected through these sorts of technologies. But it is still a growing field. And I do worry about the type of devices that are coming on the market and their what I would call relatively short life before they are superseded by even better systems. But some of the more fundamental human factors challenges still remain, and no doubt they will get solved at some point. But I think that it's definitely a growing field. You only have to just think, you just walk around any sort of cafe or area like that, and you see youngsters, 4-year-olds upwards, using a tablet device.
Yeah.
These are the devices. This is the way they are used to interacting with information. And I think that's also going to happen in the VR world. There have been many examples of VR being deployed for games on things like the Sony PlayStation. And they're not necessarily as popular as people would think. You only have to look on Gumtree or on eBay and realize that people start to sell these things after a fairly short period of time. It's because they're not doing what they thought.
Yeah.
But in terms of from an engineering point of view, this is where they will have much better capability and will be deployed. I know a number of industries are using them to support workers, to ease the work that they're doing. Even things like when you're performing a particular series of tasks, these systems can capture what you're doing. So you've got confidence that the job has been done correctly, and you've got a track record of these tasks being done. So these are really important for many, many industries. So you've got the evidence to show that the work is being done properly, or even if somebody's not doing it properly, then you can bring in additional training to make sure that they do things in the right way.
Well, it sounds to me like it's going to be a very exciting opportunity for engineers in the future, the young engineers coming through today who have a natural propensity towards this kind of technology anyway. But the work that you have done over the last 30 years has really laid the groundwork for this kind of opportunity. So it's been wonderful to have you on the show to sort of share that 30 years of history of virtual engineering, but also to think about what it's going to be like in the future. Roy, thank you very much for joining me on today's podcast. I've really enjoyed talking to you, and I'm very excited about the future. Thank you.
Yeah, me too. Thank you again.
That's all for this month. In the final episode of 2024, I'll be talking with members of the IMechE's policy team as we take a look back over the year of global engineering highlights and the impact that the IMechE has had in improving the world through engineering. You've been listening to Impulse to Innovation, the Institution of Mechanical Engineers podcast. Thanks for listening. We'd love to hear from you, so if you'd like to share any news or any feedback with us, then please email us podcast@imeche.org. All the information on this episode can be found in the episode notes.